Part I, n-theta trig equations. What I mean by that is a trig equation in the form maybe sine 3 theta equals negative root 3 over 2. First of all, you are not allowed to just divide both sides by 3. That 3 is inside your sine, so that's not going to work. What this is asking us is to find all the angles such that when you multiply them by 3 and then take the sine of that, you get negative root 3 over 2. We're still dealing with this between 0 and 2 pi. Well, I'm going to ignore the 3 for right now, and I'm going to find all the places around the unit circle where the sine is negative root 3 over 2. That occurs at 4 pi over 3 and 5 pi over 3. But rather than saying theta equals those two angles, I'm going to say the entire thing inside my sine equals those two angles. 3 theta equals 4 pi over 3, and 3 theta equals 5 pi over 3. However, there are some additional angles I need to consider. Initially, we were dealing with this for all angles between 0 and 2 pi. But my equations over here don't involve theta, they involve 3 theta. That means if I take my inequality and multiply by 3, I get 3 theta values that have to be between 0 and 6 pi, which means up to 3 times around the unit circle. I need to find additional angles coterminal to these two, up to 3 total spins around the unit circle. Well, to find the next one, I need to add 1 complete spin around the unit circle, so add 2 pi. That's like adding 6 pi over 3, so that gives me 10 pi over 3. And do it again to get 16 pi over 3. I realize that these angles are not between 0 and 2 pi, but that doesn't matter because these aren't theta values, these are 3 theta values. These are all between 0 and 6 pi. Do that again down here. We're going to find some coterminal angles to 5 pi over 3. So add 2 pi, or 6 pi over 3, to get 11 pi over 3, and 17 pi over 3. These are all my possible values for 3 theta. But I want to find just theta, so I need to divide everything by 3. And actually, I think it's going to be easier if instead of dividing by 3, we just multiply everything by 1/3. This will give values of 4 pi over 9, 5 pi over 9, 10 pi over 9, 11 pi over 9, 16 pi over 9, and 17 pi over 9. I have 6 total answers to this equation. Let's look at one more. Let's look at the equation the secant of 2 theta equals root 2. This is the same as saying the cosine of 2 theta equals 1 over root 2. Rationalize your denominator, and this becomes the cosine of 2 theta equals root 2 over 2. I need to find where along the unit circle my cosine is root 2 over 2, and that will occur at pi over 4 and 7 pi over 4. I'm going to say that 2 theta equals pi over 4, and I'm going to say that 2 theta equals 7 pi over 4. I do need to find some coterminal angles, and because I have a 2 inside here, I need to find angles up to 2 times around the unit circle. So I'm just going to add 1 complete spin over here. 8 pi over 4 gives me 9 pi over 4 for my second angle, and that's as far as I have to go there. Down here, find a coterminal angle again, and you're going to get 5 pi over 4. These are my values for 2 theta. I'm going to multiply them all by 1/2 to get final values of theta as pi over 8, 7 pi over 8, 9 pi over 8, and 15 pi over 8.